thank you. So a little bit of a different point of view, less of a research perspective from me today, and I'd like to talk more in a historical context about a project that has delivered CO2 reductions on the site and contributed to circular economy, and focus a little bit on, I guess, that what's sometimes termed the valley of death, the transition between some really excellent ideas and actually making it happen, and a 15-year journey into delivering a project. So I would like to thank you for having me. There were 3 brilliant talks. I can agree wholeheartedly with everything that's been said today. There's a lot to do in our industry, and I think on a whole, the industry is really starting to accept the challenge and stand up to it. If I just work out. Okay, so a little bit just really briefly about who Adelaide Brighton are for those that aren't local. Adelaide Brighton is a construction materials business in Australia. It goes right through from mining, quarries, cement, clinker manufacture, concrete and aggregates, and concrete products. We've got quite a few operations throughout the country, including in Tasmania, and we're well represented geographically in Australia. This is just a little bit about who we are, many different brand names, but sitting under Adelaide Brighton. So the project I want to talk about today is the burning of a biomass-rich alternate fuel in a clinker kiln. Some of the other discussions already have talked about the use of alternate fuels in the cement industry. It is only one part of our emissions. Limestone emitting that CO2 is a huge part of the technology that we need to develop to reduce our emissions. The use of fuel is obviously another major component, and that's what I want to focus on. Certainly not our only focus, but the discussion today will look at that. So the context that this project commenced under about 20 years ago was that there was a massive increase that we were seeing globally in research into what the industry terms alternate fuels, generally waste-derived fuels. And I'd say to start with, the focus on those fuels wasn't necessarily about the reduction of greenhouse gas emissions, but rather zero waste and the use of cheaper fuels, more economical fuels into our clinker kilns. So what we were seeing, and hopefully in 15 years' time we can look back and look at some of the technologies we've talked about over the last couple of days in this same way, but what we were seeing at the time was that there was an increase in the use of alternate fuels in Germany, that it was becoming technically very viable. And the type of fuel that was available to us here was what we call C&I, C&D waste, so commercial and industrial, construction and demolition. And what that waste looks like is a heavily, heavily biomass-rich, and I've got some photos later that I'll show, waste with some plastics and other components. So, like I said, at the beginning of this project, it wasn't really about the reduction of greenhouse gas emissions, it was about the use of alternate fuels. But in terms of the burning of biomass in a clinker kiln, to do that economically really does require the use of waste. So if I put it in today's view, if we were to look to, as an industry, burn a biomass-based fuel today, we'd be going down the same path and looking for alternates. It's generally accepted that, except in exceptional circumstances where maybe there's a logging industry or a large timber industry nearby a manufacturing facility, that the use of biomass fuels isn't economical, but the use of refuse-derived fuels is. So for that to work, and I won't go into a lot of detail here, for that to work though, there are a few really key components of the cement kiln. The first being high temperature. When we're burning waste, that's obviously important, and high residence time to convert any components of the waste that could be hazardous and neutralise them. The other part in a cement kiln is a lot of what we're actually talking about today. We generate calcium oxide from calcium carbonate. In doing that, we create an alkaline material in the kiln system, which can neutralise any potential issues in the combustion of the waste fuel. In addition to that, these waste fuels often contain quite a lot of ash content, 20, 30, in some cases, I've seen up to 35% solid waste. That can provide us with a good raw material. The last discussion talked about clay. You know, when we're talking about refuse-derived fuel that might have bricks that are crushed up in it that haven't been completely removed, and other materials, we actually have quite a large clay component come through with these fuels and end up in our clinker mix. It's a real benefit in a cement kiln compared to incineration plants and the like, in that it will absorb into our final product and actually turn that waste into a valuable reuse. So, like I said, the technology 15 years ago, 20 years ago was very much available. There were places that were able to burn biomass fuels. The German industry at the time was burning maybe 15 to 20% alternate fuels, and of that, maybe 3 to 5% was biomass. So it wasn't an unknown technology, but it wasn't very well adopted around the world. So we were in the early stages, and I guess the next couple of slides, I just want to take you through some of the hurdles that we went through in turning a good idea into what we have today, which is a successful project. So the first is the sourcing of materials. You always need to have enough material, waste material, fuel material to create an economical project. And in some places where we have clinker kilns, there isn't enough. The cities that surround it don't have enough population to create a viable project. Here in Adelaide, we're fortunate where there are enough waste materials available to create a viable project. From there, obviously the financial analysis is important, and that's against the fuel that you might be offsetting. But other factors that come heavily into the viability of the project are the transport and logistics. And then we start to move into environmental aspects and climate aspects. For most clinker kilns, they're located relatively close to built-up areas. That's how we get our product to market. So there will be a huge element of community consultation, and throughout this process, that's been a very, very large part of the timeline, the time that we need to take to ensure that the community are consulted with locally, but also at a state level to ensure that the local environmental agencies are on board with our solution, and we can show that there is a better off overall out of these projects. From there, there's often testing to do. We do trial plants, and then of course you're looking at then trying to finance the permanent solution. So this project went through that entire cycle, and it's gone through it 3 times since to get to the point where we are today. So just a really simple graph. The trial plant went into operation in 2003. I think we burnt about 400 tonne of material that year. From there, we had to do quite extensive trials, and it took us about 3 or 4 years to get to a point where we had a permanent facility. So this is some examples of what that looks like. So this is the actual raw material as it was in 2003. That is separated in a facility that's off-site for us. About 50% of what comes out of this waste actually ends up as our fuel, and about 45% is converted into other construction materials, and a further 5% is completely wasted. So in terms of the circular economy, this is a fantastic outcome. About 95% of what we bring in the gate actually ends up as a reused material. Following on from that, you can see in this bottom corner here, this is what the fuel looks like. This is what was the trial facility in 2004, a fairly basic facility to allow us to prove the concept. So from there, we built a permanent facility. You can see that here. It's a fully enclosed. Sorry, it's nighttime here, and my children have just come home too. So sorry about that. So we built a fully enclosed system to deliver it. Like I said, logistics in a built-up area were one of the very early hurdles that we had to overcome. And the other thing, and a lot of the time when we see ideas trying to be turned into commercial industrial sites, materials handling is another thing that becomes a hiccup in plants that run 24 hours a day, 7 days a week. So from there, we ran like that for about 7 or 8 years before I think that the early stages of really trying to focus on carbon emissions reduction in our business. We engaged through the Emissions Reduction Fund in Australia, and we built a second facility in 2014-15, and that's allowed us to do further testing, which we completed last year. That testing will take us to the extent that we can burn that fuel in our process. So that's about 45% substitution of our natural gas. At the moment, we're running at about 27 or 28% substitution, and that equates to about 70,000 tonnes of carbon dioxide emission reduction per annum. So over that 16 years, you can see it's been a process, but like I said, the outcome that we've got to now, we believe that we can reduce our fuel CO2 emissions by about 40%, which is, our long-term target is obviously to go further than that, but this biomass-based alternate fuel provides us with excellent outcomes. Over the course of the project, so last year the project celebrated its millionth tonne of RDF burnt, which is about 500,000 tonnes of greenhouse gas emissions savings. And for those who are local or understand what size a football ground is, that's enough to fill a sort of normal size football stadium in terms of the waste that's been diverted. So that's a bit of a story about, and I'm not sure how we're going for time, Ros, but that's a bit of a story about what a project looks like in reality in a clinker plant, an operating clinker plant. I guess the last things I'd like to add that aren't directly related to this project is we haven't talked a lot about lime today. CCAA is obviously cement and concrete, but Adelaide Brighton have quite large lime manufacturing facilities around the world, and I believe that lime manufacture is a real gateway to some of the technologies that will deliver for clinker manufacturing in the next 5, 10 and 15 years. So I'd just like to add that into the discussion. I know we haven't touched on it a lot in these presentations, but I think it does need to be part of those pathways. And that's it from me. Thanks, Roz.